Alrighty, hey, thanks for tuning into this video here, everybody. We're going to be talking about the inverses of functions, and I hope you're doing just great. This video was really just going to be about some of the background concepts of inverse functions. I will not be getting into the algebraic processes of finding a particular inverse function. I'll save that for another discussion. This is just going to be about the background. So, first thing about that I want to say as far as background of inverse functions is basically what they are. An inverse function is really just a function or maybe a process that undoes everything that another function does. Okay, so the function does something and then the inverse reverses everything. So here's a really pair of really simple examples. Let's say we have a nice simple linear function, f of x equals x minus 2. So I take a number x and I subtract 2. Well, the inverse of that would be simply to add 2. And so f negative 1 of x equals x plus 2. These two functions are inverses of each other. One of them undoes the other one. All right. For example, if I take a 7 and I put it into f of x, 7 minus 2 equals 5. Now, if I take that 5 and you just use it as the input into my inverse there, 5 plus 2 gives me 7. So look at those two pairs of numbers there. I have an input of 7 that gives me an output of 5. If I use the input of 5 into the inverse, I get an output of 7. Okay, just what I started with. Here's another simple example. If g of x is a function that takes x and multiplies by 3, then the inverse is a function that takes x and divides it by 3. Multiplication and division are inverse processes or inverse operations, just like addition and subtraction are inverse processes. So once again, a little input-output pair here for you. If I take g of negative 4, that's going to give me negative 12 as an output. If I take that output of negative 12 and use it as the input into my inverse function, g negative 1 of 12 equals negative 4. And you can work that out for yourself there to verify that. But so that little swap of x and y coordinates of corresponding points, that is, you might say, on functions and their inverses there. It's a very important little feature to focus on for a second. Also here, the notation, that superscript of negative 1 is a little symbol that we use to mean the inverse of a function. It's really not an exponent. Don't think of it as f to the negative 1 power, like 1 over f of x. That is not what that means. It's just a superscript. We never use f negative 2 or negative anything else, just negative 1, and it just is a superscript that means the inverse of the function called f of x. That's all it means. Okay, next kind of key idea here is going to be about the graphing, and this is a really important little idea about graphing. There's something that I really feel is very important to point out about functions and their inverses when it comes to graphing. Now, there's a nice linear function, and think about inputs and outputs. For example, that line is a function that takes a negative 4 as an input and turns it into a negative 1 as the output. That may sound a little odd here, just graphing lines, but that's what I want you to think about when you think about inverses here, is this input-output process. It also takes a negative 2 and turns it into a 0, and it takes a 0 and turns it into a 1, and a 2, it just keeps it a 2. But those are all x, y points, x and y coordinates on that line. And the x is the input and the y is the output, of course. So you're familiar with that terminology there, I'm hoping. And I just want to illustrate this idea about inverses here with this terminology. Now, if I take that point, negative 4, negative 1, and I switch places, that means on the inverse, there should be a point of negative 1, negative 4 down there. So you see that point there? That point should be on the inverse. And those other points that I've illustrated there, like negative 2, 0 becomes 0, negative 2, and then I've got a 1, 0, and the 2, 2 just kind of stays there. And just like my original f of x, my inverse is a line. All right, so there's my function and my inverse, and they're both lines, and you can see those pairs of points. And if I was to continue, or maybe you could just imagine other pairs of other coordinate pairs on those lines, and their x and y coordinates would be swapped. They would be switched places. Now, you may have noticed this, or maybe not, but there's a symmetry here. There is a line of symmetry between those two functions that is always present between a function and its inverse. And this is really important. The line y equals x is a line of symmetry between a graph of a function and its inverse. And that is a very important little feature of the graphs. And notice how that point there, 2, 2, it's on all three of them. And just think about that for a second. Well, if I'm going to switch places with two numbers, but they're both the same number, like 2, then it doesn't really do anything to switch places. It's still 2, comma 2. And of course, 2, 2 is on the line y equals x because every point on the line y equals x has x equaling y. That, 1, 1, 2, 2, 0, 0, -4, -4. All those points have the same x and y coordinates. All right, we're going to take a look at a couple of other graphs. What I want to illustrate here is this nice bold Laker colors here is this key concept that the domain and the range are interchanged. It's a nice little rhyme, and you should remember this little rhyme. It's a very important feature about inverse functions. The domain and the range are interchanged. You saw that with the x and y coordinates switching places, but it's true for every single point. In fact, the entire domain of one function becomes the entire range of the inverse, okay? And vice versa. The domain and range are interchanged. Let's look at a couple of other graphs. Here's a graph that I bet you're probably familiar with. It's a parabola, y equals x squared minus 3. And it has a y-intercept of -3, and has a few other points there that I've illustrated, which you can look at. Okay, and the important thing here is that the domain of every parabola is all real numbers. Okay, so the real negative infinity to infinity is the domain, and the range is from -3 to infinity on this here parabola. Okay, so there's the domain and range of that parabola, and what we're going to do is we're going to flip it across the line y equals x and see what happens then. But I want you to focus on those first 3 points that I drew. That'll be the easiest ones to sort of focus on. For example, that when I take the line y equals x there and I flip those points across that line, that y-intercept of -3 becomes an x-intercept of -3. Okay, and so those other 2 points that you see, they're kind of aligned in a similar fashion there, reflecting across the line y equals x. And if we fill it out, we can see how the parabola is going to look. It's a sideways parabola, okay? And I put the equation there, y equals plus or minus the square root of x plus 3. You don't really need to worry about that. Don't get troubled by that equation. I just kind of put it in there just to be complete. But the important thing is the domain and the range are interchanged. Now it's the domain goes from -3 to infinity, and it's the range that's all real numbers. Okay? So you can see that, once again, the domain and the range are interchanged. So let's see another one here. I'll show you. This is a kind of cool one here. Exponential function of y equals 2 to the x, and there's our line y equals x, okay, our line of symmetry. And if I reflect that curve, very simple curve really, across that line, it looks like this. Now, that has an equation that you may or may not know much about. If you don't worry about it. You're going to be a master of log functions in a little while. But I wanted to illustrate this to you for the purposes of showing how the domain and the range are interchanged. So you can see that on the red function, it's the domain is all real numbers and the range is y greater than 0. Whereas if you you interchange places with those two things, on the green function, it's the domain that's greater than 0 and it's the range that's all real numbers. Once again, the domain and range are interchanged. Okay, it's time for a little summary here of concepts of this video. And the first one, of course, was about what a function, that is what an inverse function basically is. It's just a function that undoes another function, or it could be another process. Undoes everything in another process. You can think of it that way too. Next concept was really more about the notation. A very important little feature here, so that you know what you're reading when you see f -1. You're reading there the inverse of something called f of x. So it's just a way of kind of pairing up a function and its own inverse with that little superscript of -1. Next is about the graphs. The graph of a function and its inverse are symmetrical around the line y equals x. Very important feature about graphs. graphs of functions and their inverses. Okay, and the last concept here was our little rhyme. The domain and range are interchanged. So don't forget that thing. It's really important. And this is just the background concepts of functions. I hope you enjoyed it. And I hope you're in great spirits. And now go do some math.